everyone, my name is Kristen Satch and I work at WSB. Today we'll be hearing from John Makowitz, WSB's Vice President of Technology. He will be discussing how using high-resolution 360-degree imagery works for reality capture and asset inventories. Okay, John, I'll pass it over to you.
Thanks, Kristen, for the intro, and thanks everyone for joining me on this kind of gloomy day here, at least in Minneapolis. Kristen did a really good job kind of talking about the high-level topics we'll be talking about. So what we're doing at WSB is some really interesting stuff with taking high-resolution 4K imagery. It's a 360 camera, so it shoots forward, sideways, and backwards, and it's mounted on top of a vehicle and captures street view imagery. And this imagery can be used to upload it to Google. It can be viewed out of a GIS browser. And so this can be some really useful data for people to take a look at what's going on in your community. Now, Google's already captured this in some locations, but there's a lot of small communities in Minnesota that don't have this. And there's other communities, depending on your size. This can be updated every 4 years. It can be updated every 10 years. So just getting out and capturing the imagery has been a very powerful tool for a lot of communities in Minnesota, Texas, and in Colorado. And we're doing this, in residential areas at slower speeds, but we've actually tested this up to 45 to 65 miles an hour on highways and been able to capture this imagery because we are shooting at a very high frame rate and at a high resolution. So earlier this year, we started testing this technology to do object classification and object capture. So what we're doing is we're taking the imagery and we know the location that the pictures were taken. We know the location of the first image, the second image, the third image in a series, and using some basic geometry, we can actually calculate the location of the assets in the image and then use some artificial intelligence to classify whether it's a stop sign, whether it's a fire hydrant, whether it's a yield sign, and do some really, really cool stuff that's actually pretty accurately mapped. What this looks like once you get it mapped is you can see on the left-hand side, you'll see the street view imagery, and it drops symbols right on top of the signs. You can see on the right-hand side here from an overview that it's dropping those maps right in the GIS. And you see it's got some project boundaries and it's also got some guardrails that were captured as well. So all this information is picked right out of the imagery. And I can stop here for a second and show this in a GIS to give you a better view of exactly what this looks like. So in the GIS, you'll see this is one area we captured, and we drove actually the service road in this area out in Plymouth. And if I drag my little guy here in the GIS and drop him on the image, you can see the location he's facing. And you can also see that as I pan this around, you can see that this was shot actually just recently when we had a little bit of a late season snowfall. So if I pan this to the side here, I got to back up a little bit more. Maybe I'll make my image a little bit larger too. You can see here, the stop sign is the one that appears in the GIS map. If I pan my map to the side here, you'll see the stop sign there. You can actually see that it's picking up the stop sign that is on the way onto Olson Memorial Highway, and it's actually picking up the do not enter sign and the yield sign in the median. Now, if you're asking how does it pick up the yield sign, what's looking at the back, we actually drive intersections in multiple directions, so we make sure that we pick up all those signs. Additionally, you'll see here that it picked up the stop sign in the opposite direction, and it picked up this other sign a little bit, the curve warning sign a little bit further down the road. That was actually picked up by the rear-facing camera. So for a two-lane road, we're driving these in one direction and picking up assets on the sides, in front, and behind the vehicles. When we get to four-lane roads with medians, we're actually driving this in both directions and driving the intersections. So we're really confident that we're picking up all the assets, and really the more directions you shoot it from, the more accurate of a location that you're going to get to as well. I'm going to switch back here to my PowerPoint, and at the same time, I did see a couple of hands shoot up already. So Kristen, do you have a couple of questions?
Yeah, we've got one member asking, have you collected data like this before construction?
Yeah, that's a great question. We've seen communities use this both before and after. So it's really cost effective to collect this. So what they'll do is before construction even starts, drive the street. And what you can do then is you pick up existing conditions, where signs are, the conditions of driveways, the conditions at intersecting streets, where existing infrastructure is. And then if you drive it again after the project is done, you can get the condition of those same assets if they're still in place, like driveways, or pick up all the locations of the signs and other assets that you can see when they're installed. It's actually a really interesting technique when you combine it with some other technologies like BIM, because you can take what's in the design and then verify that that has actually been constructed and built out in the field after construction is done.
Okay. We've got one more for you. Can you merge this data with existing GIS data?
Yeah, that's another great question. And the answer is yes. So this is a completely GIS-based process. So if you did have existing information about signs that maybe was survey grade accurate, or maybe you had information about the posts and you go out and inventory it, you can link that information together. So you can take the new imagery and the new data that's picked up from that and merge it together based on spatial joins with what already is in your GIS database. There's a lot of different tools and a lot of different ways that you can do this. It really comes down to what you need in your city, county, or state agency at the time, and how we can make that work. I think it's really important to reiterate that it's a GIS-based process. So we get this information to the GIS, and then we have all the tools that are normally available in a GIS to work on top of this data. I think I'm going to jump into this next slide and then answer any additional questions at the end, just to keep things moving here. So I talked about signs before, and the list of assets that we can pick up with this is growing every day. And we're adding these a couple different ways. We've got a national software vendor we're working with that does some of the AI. We're also working with some hardware vendors to pick up some of this straight through the hardware. But the important thing here is that there's a ton of different traffic signs, 1,500 different traffic signs that we can currently classify. And that list is growing. And if there are custom signs, like every city and county has, those can be added to our algorithm, or added manually if there's just a handful of them. Linear features, able to pick up a lot of other things, lane markings, guardrails, rail tracks, roads. There are a ton of new features that we're adding again every day to this. The most obvious ones are the signs, traffic lights, traffic poles, and other assets that are in the right of way. But I mean, we've got things in here like bike racks, CCTV, hydrants, mailboxes. So there really is a ton of different information that you can pick up, whether it's in a neighborhood or on a county road using this technology. Again, the key part is this can then be merged into your GIS and asset management system. So accuracy. So there's a few different things. Attribute accuracy, spatial accuracy is the one that people talk about the most here. And so we're seeing 2 to 3 foot accuracy for most signs. We're seeing a significant number of the signs that we collect with a location accuracy of less than a foot. And the worst we're seeing is like between 3 and 5 feet. So some really good spatial accuracy here for things you can see. If this was a buried utility, I don't think 2 to 3 foot accuracy would be accurate enough. But with it's a sign, it's on the right corner, it's in the right location, it's not in the middle of the right of way. This to me is some pretty compelling accuracy to be picked up with just imagery techniques. Like I said before, it picks up signs at a distance, and it also picks up both sides of the road and across intersections. So as we started to push the envelope on this and take a look at what other assets we could map, the first thing we really looked at was guardrails. One, because it was a linear asset, and two, because there's some needs to map this. And in our testing, what we've seen so far is that the guardrail length, a length of any stretch of guardrail, is accurate to within 5 feet, which makes a lot of sense to me when you think about if a sign point is accurate within 2 to 3 feet, that you've got 2 ends to the guardrail, and in total the accuracy is going to be about 5 feet. So that's both the positional accuracy how where the start and end are, and then the overall length of the guardrail too. I actually think that the accuracy, once we do a little bit more validation and get a larger sample size, is going to improve. But right now, that's what I'm willing to commit to. Some of the other things that are interesting is you can tell between temporary construction barriers and permanent guardrails. And we're working on um, improving that and getting even more classifications of the guardrails added in the future so we can break that down even further. So this image was not my attempt at watercolor painting on a computer. This is actually what the AI algorithm is seeing. So as you look to the side, it sees, some greenery, it picks up some sky, it picks up the roadway, and then it actually picks up the guardrail. And you'll notice that it's looking at a profile of this now. So it actually isn't seeing a straight line, but when we take that and put it into plan view, it actually ends up being a nice clean line for classification of the guardrail. So it's to me, it's interesting to see what the computer and what the AI is actually seeing, because it makes a lot of sense in that it's picking that right out of the imagery. And if I shift back to GIS now, can switch here to this area where we ran some guardrail classification. And you'll see in the GIS view, you can see the guardrail, and you can see that it goes right into the image and comes around rounded nicely around the corners. So if I do the same thing as in the previous example, and I want to take a look at what this looks like in the street view, you'll see here, you can see the back of the truck that I showed in that first slide, but you'll see here that it rounds right around this corner and that corner. Now, what was interesting to me is when I was going through this and doing a little bit of quality control, the first image I saw was actually some older Google Maps imagery that was taken. And if you look at this image, you'll see that this taken back in 2007. And even if I move this one forward to 2007, you'll see that it looked very different in that intersection, in that it's got a rounded one here. The one on the side here terminates and doesn't go around the corner. There's no guardrail here, and there's no guardrail there at all. So at first I thought that the AI classified things incorrectly, but then once I went back and I started to look at the actual imagery that our classification was based on, you could see that those guardrails were actually installed between 2007 and 2020. So, to me, the interesting part about that is that, a lot of people concentrate on the spatial accuracy, whether that's accurate to within, a foot or an inch or 2 feet. But really, we're talking about temporal accuracy here. And that if you can't and you don't go and classify data or collect data because it's too expensive to run out there and get survey grade accuracy on all this, you've either got really out of date information or you've got no data at all. So I would make a pretty strong argument that with an accuracy of 2 to 3 feet, going out and using this technology to pick up the location of guardrails and other visible assets has a real distinct advantage to using more accurate techniques, just because you can afford to go collect the data. You can afford to pick up the assets and get an inventory. Even if it's not accurate to an inch, it's accurate to within a couple feet, and it's up to date, which to me is very, very important when we talk about completing these inventories and in managing spatial data for our communities. No, that's not to say that there isn't a time and place, especially for buried and underground assets and utilities that have a real need for high levels of spatial accuracy. But for a lot of these that are visible, again, I think that the accuracy provided by this is more than or better than what we need. So I've just got one last slide here, and then I'll go back to questions. We're pushing the envelope on this a little bit. And the next thing that we're looking at is how we can do pavement classifications. And you'll see here on the lower right where it shows the actual distresses being mapped. So the AI is actually picking up cracks in the roadway. And you can see we're looking at some sample zones, and they're showing that up on the upper right. This is not quite fine-tuned. There's probably some programmers at WSB that are groaning that I'm talking about this, but this is where this is going. And we're getting to the point now where I'm confident that we're going to be able to identify different types of pavement distresses, different types of cracking, and start to do some really great pavement analysis and classification based on AI, which again, all the advantages I just talked about for collecting sign assets and guardrail assets, being able to do pavement surveys and condition assessments has been cost prohibitive for some communities. And I think technology like this is going to open up a lot of opportunities for people to better manage their pavement assets moving forward. So with that, I will take any additional questions that have come up.
Yeah, the first one is, does this data tie to asset management systems?
So any of the data that we're collecting goes into the GIS. So if your GIS is tied to your asset management system, this data is going to go right into your asset management system. If your asset management system isn't tied to the GIS, I mean, there's a few out there. Most of them are linked to the GIS these days. But we've worked with a few of those and then created an import export that takes the data, excuse me, out of the GIS and then imports it into the asset management system. So the answer is yes. It just depends on the specifics of what asset management system you're running.
Okay. It looks like our final question here, are you using LiDAR to capture this information?
We're not using LiDAR. So WSB uses LiDAR in some other use cases. But for this exercise, we're using straight imagery. And the reason for that is cost and speed of acquisition, and that we don't need to use LiDAR to get the accuracy that we need for these applications. If you came to me and said, hey, we need to do a sign inventory and we need to have it accurate to within an inch, I'd give you a number that's probably about 3 times higher than it would cost to do this, and we'd go use LiDAR to do it. I've kind of tipped my hand that I'm a little bit passionate about that this can be done with sufficient accuracy to meet the needs of most people. And but if it doesn't, there are other applications, whether it's using LiDAR, whether it's using vehicle-based LiDAR, ground-based LiDAR, drone-based LiDAR. There's probably room for another webcast on that. And maybe that's a topic for another day. But for this, we're not using LiDAR.
Okay. Well, that's all we have for today. Thanks so much, John, and until next time.
Thanks, Kristen, and thanks everyone for joining us today.